Here, for your amusement and interest, are a collection of quotes from 1623 up until the present, not all of which I agree with. So the key themes, however, are fairly consistent. The centrality of mathematics in understanding physical reality, the rigour of mathematical reasoning, the universality of mathematics across all the quantitative disciplines, and indeed across all possible worlds, elegance, beauty, and the depth of mathematical reasoning. So, Galileo was an astronomer, physicist and mathematician born in 1564, and he believed, correctly of course, that the Earth and the planets rotated around the Sun. But he was forced to recant this position under threat of torture by the Inquisition. It was permissible for him to calculate this way, but it was not permissible for him to deny that the Earth was the centre of the universe. The 1771 Encyclopaedia Britannica has the interesting quote, which in part is, "There can be no disputes among wrangling disputants." The mathematician Simeon Poisson, in 1800 or so, takes a rather narrow view of the good life, and Gauss, perhaps the greatest mathematician of all time, talks about mathematics as the queen of the sciences. Bertrand Russell was a philosopher, a mathematician, a writer and a political activist. He won the Nobel Prize for Literature. He has some interesting but cryptic remarks about the axiomatic method and the universality of mathematics. Russell and Whitehead together wrote the 3-volume treatise Principia Mathematica, published in 1910, 11 and 12 in 3 volumes, about 1,000 pages, and its goal was to formalise all of mathematics and hopefully avoid the contradictions such as arise from the assumption about there being, let's say, a set of all sets and other types of contradictions of this form. Nowadays, there are simpler ways of doing this, namely the Zermelo-Fraenkel axioms for set theory, which I actually discuss a little in the course notes chapter on infinity. Whitehead talks of the difficulty of grasping the extent of mathematics. Hogwood Jeans describes the universe as a mathematical construction. Emmy Noether is famous for her contributions to both algebra and mathematical physics, speaks of proofs which give insight. Interesting story is that Noether was first invited by Hilbert, David Hilbert is mentioned in the video More on Proof, to join the Göttingen Faculty of Mathematics. Members of other departments objected because she would have been the first woman professor at the university. Hilbert's rather sarcastic reply was, "The faculty is not a bathhouse." Hardy, the famous Cambridge mathematician, who you may remember from the movie about Ramanujan, he arranged for Ramanujan to come to Cambridge from India, talks of the patterns and ideas of mathematics. And the Nobel Prize winner in physics, Eugene Wigner, talks about the unreasonable effectiveness of mathematics. Freeman Dyson is a physicist and mathematician. He talks about the pathological structures that arise in mathematics, in particular in chaos and fractals, and they form one of the 4 modules in this text. Hirsch, Halmos and Thurston all talk about learning mathematics and the nature of mathematics. David Deutsch and Max Tegmark are interesting. They are contemporary computer scientists and astrophysicists. They argue that quantum mechanics points to there being infinitely many multi- or parallel universes, and largely explained by, and which in Tegmark's view are, mathematical constructions.